Oh, sure. Okay, we are now live. So thank you everybody for joining. I'm going to just share my screen. Okay, just in case you're not sure where you are, this is Cloud Native London. So we're on Twitter at Cloud Native Lon, and we are going to kick off tonight's event in about 15 minutes following this timer. So we'll just have 15 minutes to wait for people to join and to just keep chatting. So I think all the speakers are on already, and we're having quite a good conversation about serverless versus Kubernetes. So yeah, just feel free to keep chatting.
Oh, now I'm on the record.
All of a sudden it's real, right? Yeah.
Actually, since we were talking about serverless versus Kubernetes, we were playing around with Knative about a year ago, but I haven't heard a lot since. So I think then they skipped one major version, and then it was kind of maybe we as a project also moved from Knative to plain Kubernetes, because for us it wasn't the right choice. But is there any, like, what was the progress on Knative? Do you know, Josh?
I mean, it hit GA a while ago. I mean, I normally berate people for saying it's serverless on Kubernetes, because for me that's antithetical. Like, it's an event-driven architecture on top of Kubernetes, which is a wonderful thing. But I think a lot of people like confuse the two terms, and I have argued with some Google people about that in the past. But I think it's right. Like, if you can do event-driven architectures, generally you end up in a really good spot. So I kind of like the idea. But a lot of the time, if you're doing event-driven architectures and you happen to be on AWS, you're probably better off with Lambda a lot of the time.
Yeah.
But a lot of the time I see people reach for Kubernetes, and when I suggest to people that they reach that way, it's normally because they're doing something that can't really be event-driven or is sufficient scale, right? Where Lambda gets expensive. But
yeah,
there's lots of other ones. There's like Kata and stuff like that as well. There's so many event-driven like Kubernetes solutions now. It's a bit of a saturated market, to be honest.
But Knative, they even mention they are you can manage more than serverless workloads on Knative. That kind of indicates it's for serverless workloads, because it's like the first sentence on the website.
Yeah, no, I think people in the serverless community generally get annoyed when they say it's like, I mean, the idea is it's event driven, right? So you fire events in and things happen, which is generally a really nice way to decompose distributed systems at all. It's very much Alan Kay's original object-oriented way of looking, where it's passing messages between, not remote procedure calls. So it does make some really nice patterns, and it does give you like a way that if you go serverless and want to go back to Kubernetes, then you can look at that as a vehicle to get you there. I mean, if you look at Azure, they've got like full interoperability between Azure functions, and I think it's Kata on top of Kubernetes that allows you to actually just run the exact same thing in both places. Mm-hmm. Probably because they're running Kubernetes under the hood for Azure anyway, so it's a very easy transition. But AWS haven't got anything like that yet. But Knative is like, you know, if you start with Cloud Functions or something like that, and you like, actually, I want to move to GKE for scale or some other reason, then you have a much nicer pathway back, or potentially you went Kubernetes and you went, actually, this is a bit too much effort and I'm not at the scale I want, so I'll run back to serverless and do it that way. But I think they're interesting projects, right? Like, I think the world's kind of coming around to more event-driven stuff. Like with event sourcing and CQRS and all that kind of way of doing distributed systems, that actually looking at everything through events, like Yudi Dahan and the whole DDD community have been saying it for a long time, and I'm kind of not wanting to admit that they're right, but they kind of are at the same time. That way of looking at systems is generally good, right? Like if you take like a remote RPC, like an RPC call, replaying that is quite a difficult thing to wrap your head around. Like you can do it, but you've got to figure out like what the context within that you're operating, like what the transaction you're operating in and all that kind of stuff. But if you move to events, you just replay events.
Yeah.
And if you replay the events in the same order, then you end up in a good spot generally, right? So yeah, I don't know. I think it's interesting. I think pushing people towards event-driven architecture is generally a good thing because that gives you more granular scalability than anything else.
Yeah.
But
yeah,
I don't know a lot of people using Menanga, to be honest.
I also like event-driven architecture, and actually, I'm part of an open source project which is heavily event-based. So we are incorporating this concept. But for what I liked about Knative, the good part of Knative was that everything still was kind of a pod or some the smallest unit they had was a pod and not something not directly the source code. But so you had your pod, you had your basically you had your container image, and you had all your dependencies already inside this container image. So you could just scale those also down to 0, and then if some event fires, then Knative will create one instance of it instead of like in Kubernetes, you usually have at least one up and running all the time. So the principal idea was quite nice, but if you not already have Knative somewhere up and running, then having Knative just for one application, it's kind of at the times it was kind of a heavy framework you put on top of Kubernetes. So first you have Kubernetes, then you put another heavy framework on top of this for running serverless applications on your.
Yeah, if I remember, it doesn't anymore. But Knative used to have like a requirement on Istio. I think you can replace that Istio requirement with some other gateway integration. But that's a lot of operational overhead to accept. Like Istio is amazing if you have the right problems, and if those problems are the highest priority thing to look at. It's, you know, there's a certain level of maturity where looking at service mesh is the right thing. I always get concerned people reach for it too quickly. When it's like, is it really the biggest problem you have right now? Really? Are you sure? But I think generally, because I deal with a lot of enterprises in my day job, that generally they try and reach for the big whizzy bang solution. It's like, please don't. Please just wait. You can deal without a service mesh for a long time. Like I've run production Kubernetes systems doing big scale without Istio for a long time, and everything's fine, right? And it was never the most pressing problem to pick it up and drop it on, as much as it does amazing things. But yeah, Knative being built on top of that always made me a bit scared.
It's another component you have to manage, you have to update, you have to maintain. So we usually saw a pushback that the companies and organizations we work with, they did not like the fact when we told them we want to have Istio as part of our installation procedure. But things might have already changed, and there are other service meshes out there. So I think Istio is still the most well-known service mesh, but there are others out there that are. I think in the future it will be integrated in a lot of different distributions, some kind of service mesh, because eventually you want to have it, but not in the very beginning, because you don't want to fight with this additional complexity. That's what we see.
Yeah, once service meshes become boring, like as technology goes through that kind of journey, right? Like eventually stuff becomes boring. And Kubernetes for me is kind of there now. I mean, it's been around for quite a number of years. For a lot of people, like KubeCon kind of went through a transition of talking to about service meshes and a lot of other things and kind of add-ons on top, whereas the Kubernetes stuff kind of went, yeah, everyone knows that now. Let's move on. And I do think service meshes will get there eventually, as everything kind of does. I'm interested to see like some like in the serverless space what a service mesh equivalent could look like, getting a lot of the kind of nice features out of it within Lambda. Maybe I'm preempting reInvent. I have no idea this year of what they're going to announce for Lambda, but you know, being able to do the canarying in a nice way, which you kind of can do in Lambda and that kind of stuff. But a lot of the circuit breakers and traffic mirroring is always a really big one for me that I'd love to have as a first-class citizen in a serverless environment is having the full traffic mirror, because that's really nice. And Istio is kind of the only one that seems to really do that. Maybe Linkerd does now, but it didn't. But again, these are all nice problems that I'd love to have, but I never do because there's always other things which are are on fire now. And, you know, there's always these nice bells and whistles. Like I've put Istio on clients and then taken it off, being like, this is what it would look like if you had it, and this is all the things it would solve. But given those are the problems it solves, so those are the problems you want to solve right now. And the answer, whenever you talk to anyone from business, is no. Sometimes the techies want to do it because it's interesting, right? But
hi, this is Anurag here, and something interesting we're talking about here. Want to know if anyone is working on cloud native for edge computing, like cloudlets, etc. What are the interesting problems if anyone has come across? So service mesh there is interesting because it's all about workload convergence. It's premium real estate there. We have multiple services. How do we connect, etc. So that's why it is interesting conversation from my angle. I just want to know if anyone has here experience. What are the things people are talking about? If any is working on edge computing.
Are you talking about something like yes?
Sorry, you go, mate.
So we stumbled upon K3S or Keys. I think they claim themselves to be ready for like edge computing, IoT devices, these kind of things. It's basically you can run Kubernetes, a very small Kubernetes distribution within one binary, and just put it on a very small VM or maybe even a Raspberry, some kind of these. And we experimented a little bit with this to also get our open source project up and running on K3S, because it's basically when you just want to have our project as a control plane somewhere up and running without installing it into a production Kubernetes cluster, because you just want like the control plane where you connect other services that are living in other clusters. It worked very well for us. Really, really well. So it was K3S, K3S.io. I think it's from Rancher. They are building this.
Yeah, it is a Rancher one, and there's like Alex Ellis, the guy who wrote OpenFairs, and all of them wrote like a cool talk. He said it's pronounced ketchup, that effectively makes a K3S install like the simplest thing I've ever seen. I've got it running on my Raspberry Pi cluster, like just on the other side of the wall. The other option with Edge is, yeah, you can either go, I want clusters everywhere, or you can run something. There's an open source project called KubeEdge as well that runs like a centralized Kubernetes cluster that kind of controls kind of remote nodes, as opposed to putting a cluster everywhere. Instead, you have like one cluster that goes all the way down, which is an interesting solution. I evaluated it for a client, and when I don't think it's mature enough yet, but that was quite a while ago now, for them to adopt at that point in time. But I think there is some interesting use cases depending on what you want to do. Like if you want to run a whole system that can kind of self-service, then you'd kind of need Kubernetes at the edge. Otherwise, you can get away with just nodes at the edge.
Yeah, I think so. We've looked at KubeEdge also, and that solves one of the problems. How do you get our software, etc. This is, I'm talking from work point of view. So essentially, this is about what we call access nodes. So you have a cloud native solution on the base station side and more on the telco edge side, etc. How do you deploy applications, your time sensitive, latency sensitive applications there? And so a lot of conversations we had earlier about serverless and event driven. So that's also very significant there. So this is great to have that conversation. Thanks, guys.
You know, I'm not like an expert about Edge, but I know that we've got, I mean, we like on Azure, we've got like a lot of solution about Edge, and like there's IoT Hub, Edge Hub, I believe, and something like that. And I know that you can deploy containers with, for instance, stream analytics and like do some computation either on those Edge devices or like stream it to the cloud and then do the computation. So I think it's pretty much mature, but I'm totally not, you know, in this like department doing that. But yeah,
no, that's you're right. You're right. Azure is quite relevant there. But what we're finding is that may not necessarily be, at this moment, may not necessarily be popular with the customers. And kind of they are going like, they're being very cautious there, maybe business model, maybe pricing, whatever. So let's see how it plays actually. People prefer Kubernetes, standard Kubernetes over Azure-based solutions.
Sure, I know that you can deploy like containers for sure on those edge devices, but yeah, I'm totally not, deep there.
No, thanks for your input, yes.
Last 5 seconds. Someone wants to get a last thought in. Okay, and we are kicking off. So thank you everybody who's joined us on Zoom. There's also people who are joining us on YouTube through the live stream. So welcome to all of you. This is Cloud Native London. And tonight we're going to have 3 talks from our speakers. So Juergen's going to talk about Prometheus and scalability. Then Josh is going to talk us through serverless versus Kubernetes. And then we'll have a 15-minute break. And then Alicja will be talking about scaling petabytes and analytics on Postgres on Azure. So then we're going to wrap up at 9 p.m. UK time. So I'm going to do a very short introduction before handing over to our speakers. But if you've got questions, please put them in the chat. We'll be following both the Zoom chat and the YouTube live stream chat, and we'll forward the questions onto the speakers as we go along. A little introduction for us. So Cloud Native London is a strong, open, diverse developer community dedicated to the cloud native platform and technologies, usually in London, today coming to you from all over the place. I'm Cheryl. I'm the Director of Ecosystem at the CNCF, which is the home of Kubernetes, Prometheus, Envoy, lots and lots of other projects in this space. And you can find me on Twitter at @OiCheryl. So I like to start off by asking people a little bit about what they're doing and how they're using Cloud Native. So if you have your phone or laptop handy, please grab that now and go to this link, oicheryl.com/p. So this is going to redirect you to a service called Poll Everywhere, where you can follow along and answer some questions on your phone. So you don't need to download anything. It's just a way for us to get to know each other and find out what everybody else is doing. So I'm going to start with asking 3 questions about you. And then I'm going to do 3 questions on how you use Cloud Native. And I'll ask the speakers that we have tonight to comment on the results as they're coming in. Just bear in mind that if you're watching this on YouTube, there's a roughly 10-second delay between Zoom and YouTube. So I'm going to leave the questions on the screen a little bit longer so you can get a chance to see it. Okay, first questions. So is this your first time at Cloud Native London? So you should see 2 buttons, yes and no, and please hit whichever one of those if this is your first time or if this is not. This is going to be a very slow poll if people don't actually answer the question. So can I actually confirm people are actually seeing the poll if anyone has it on their phone?
Well, on my desktop also, it is there.
Okay, so you can actually see the poll and you can actually get the answers,
we can vote as well.
Yep.
Okay.
But it doesn't
Strange.
reflect
I
on your
wonder why
screen.
I'm not seeing results. Why do I have a timer here? Huh. So this is interesting. I have not seen this before. Ah, the joys of a meetup and the tech. Being your own AV support for your meetup, huh?
You can't blame tech.
Yeah,
Show responses. There we go. That's the thing I want. Sweet. Okay. There we go. It's not the fault of the tech. It's user error. All right. So what have we got? 63% of people are saying that it's not their first time. Yeah, about 40% saying it is their first time. So that's pretty awesome. I'm always happy to see people joining for the first time. Just see if any of the results continue to change. I think it's probably pretty stable. So yeah, like 40% new people, 60% returns. So awesome. Welcome to everybody. Let's move to the next question. Okay, where are you right now? So you should see an image with a couple of options. If you're in London, then you can put a point to say where you are in London or in the UK or the rest of the world. And once again, yeah, I can see some live results coming in. Cool, awesome. I would love to know who's joining from somewhere down here. Please feel free to introduce yourself and say hello if you want to. In fact, I haven't even asked our speakers. Where are all three of you?
I'm in Warsaw.
You're in Warsaw?
Twyford, not too far from London, but outside of London.
I'm in close to Linz in Austria, so a little bit further away from London.
Awesome.
Pretty much central London.
So I'm in Camden, so also quite central London. But I think this is a nice thing about virtual events, that we can join from different places. Okay, I think the results have slowed. So last question about you. Okay, so what is your job title? Just pick the closest one to it if it's not exact. Okay, so looks like SRE, DevOps engineers and architects are in the lead.
Oh, that's a nice race.
No application developers. That's interesting. SRE is just pulling ahead a little bit. Okay, cool. So I think this is pretty typical of past times I've run this poll, actually. It's sort of primarily SRE, DevOps engineers, and then a mix of other ones. So again, welcome everybody. Thank you for following along with the poll. And I'm going to ask you some questions about how you're using cloud native. But first of all, let me just, again, welcome to our three speakers. So I'm going to ask three questions which are related to each of the topics that Juergen, Josh, and Alicja are speaking about tonight. And then I'd like the three speakers to just discuss the results as they're coming in and anything they thought was interesting. Okay, first question. How much effort is it currently for you to enable monitoring, dashboarding, and alerting of a new app? So your options are mainly a manual effort, you automate it based on custom scripts, you automate it with something out of the box, or you use a mix, or anything else. Like maybe you don't monitor at all.
Cool. Great to see that no one is doing it manually. That's already a good choice. Oh,
you spoke too soon.
Yeah, you jinxed it,
and
mate.
back to zero.
Maybe someone made a mistake. Or maybe someone said, like, I don't want to admit to doing it manually.
Yeah. Yeah, actually, we've seen all of those options all over the place. So it just depends on the level of automation. So you could also see like no automation, a little bit of automation, self-made automation, then like using out-of-the-box automation, or apparently most of those folks joining are like doing a little bit of their homemade automation and using automation tools, out-of-the-box tools. Which is
Cool.
great to
Any
see
other
that
thoughts?
automation plays a huge part.
Cool. Any other
For
thoughts?
some silicon companies, when we are building up technology ground up, that is the first port of call anyway. So you get through the manual efforts, then you build tools, and you fit it into cloud native, and then that's the path we take.
Absolutely, shows the maturity. The more automation you have, the more mature you usually are.
Cool. I think that the answers seem to have settled a bit. So pretty clear mix of like clear winner here is mixture of all of automation and manual, which I think makes sense. Let's go to the next question. What is the future of application development? So do you think it's Kubernetes? Do you think it's serverless? Do you think it's something else? What are your opinions? And if you say something else, I would love if you put it into the chat. You can see what you think is the future.
So actually, it will always be a mix, isn't it? That option is not there. So maybe that is something else.
Oh, I think Brian said the same thing.
Maybe the dominant future, maybe, I guess. What you think will be the majority?
So in the next 5 years to maybe that horizon, it would still be Kubernetes, and maybe beyond that, probably serverless. And before that, actually, within 2 to 3 years, surprisingly, especially for the edge community, it might there would be a lot of infrastructure as a service component also.
Danny says probably a hybrid approach, something between Kubernetes and serverless. Any other thoughts, particularly from Josh?
Yeah.
Oh, go ahead.
A lot of time, actually, people develop comfort level with one technology, especially risk-averse telco operators, etc. So that's the inertia that you have to deal with for some time. But definitely, the cloud service providers, the hyperscalers, are definitely in the serverless domain, and we're still pushing for Kubernetes into the telcos.
Yeah, I think it's important to think of serverless is not just Lambda or Cloud Functions, right? It's much wider than that. It's not just functions as a service, which are an amazing thing, but they are not by themselves the whole of serverless, right? Yeah, it's
and actually it's so fascinating. Actually, when we talk about OT, the operational technology, then a lot of things, hardware acceleration, that's how nicely that fits with serverless. When we talk about latency sensitive applications, how nicely that fits in with that. But then you have security concerns, isolation concerns, etc., especially for a production environment, especially for a when you want 5 nines sort of operation. So that's where you have both challenges there.
So I see a comment in the chat. Someone says mixed hybrid with edge level computing and device distribution. Somebody else says specifically, I think applications will be developed in a serverless fashion on Kubernetes. Either of you like to comment?
Well, I think like Kelsey Hightower, who I'm assuming most people are aware of in the Kubernetes community, has effectively said he expects that kind of everything below the control plane will eventually kind of drift into fully managed to the point where serverless and Kubernetes kind of start to blend. So that might be what Michael is meaning on the serverless fashion on Kubernetes, is a lot of the management that you take on right now might well disappear almost entirely. Or if he's meaning like event-driven architectures on Kubernetes with OpenFaaS or Knative or Knative or something like that, then yeah, quite possibly as well.
Cool. Okay, let's go to the third question for tonight, or the last question for tonight. So are you familiar with Postgres? So your options are yes, very, yes, somewhat, not really, or not at all.
And a don't care option, maybe. Not really.
You can say, yeah. Actually,
Okay.
yeah, what do you put then? Not really, maybe.
Okay, so pretty many people are at least a bit familiar with Postgres, so that's great. Okay.
Sorry, I didn't mean to say that this is not important. What I meant to say that for people like us is we work at very low at the platform level. How do you enable different technologies? So for example, and this is something that could be an interesting conversation, when you swap data in and out of memory. So those are the things that excite us, right? And what you do with it on top of that, how you build the applications. So yeah, that's why I said I don't care, but didn't mean to say that that's not important.
Okay. I don't mind.
Awesome.
Okay.
Cool. I think that's settled pretty nicely. Looks like, as you said, most people are somewhat familiar with Postgres. Yeah, 12% people not familiar at all. Interesting.
Yeah. And
Okay, so
it seems to be we've got some like Postgres experts as well, like this 4%.
cool. Okay, awesome. So that concludes the live polling for today. So I want to thank everybody for playing along and telling us a little bit about yourself and where you are. So we're going to go back to tonight's agenda. So first of all, I'm going to ask some of our sponsors to say just a line or two about what they're doing. So see if anyone's on from Technovo. Okay, Ashley, do you want to talk about Palo Alto Networks?
Sure, yes, thank you. Ashley Ward, Palo Alto Networks. Palo Alto Networks, you might think of big firewall boxes. That's certainly the background of the company. Company has embraced digital transformation and we want to be part of that journey. And so we have developed a suite of products. The suite of products is called Prisma Cloud, and it's for securing all your cloud native things, whether they're running on premise or whether they're running in public cloud. So all the nice Gartner terms, but all that stuff around your public cloud accounts, the stuff you're running in there, their configuration, their runtime protection, all of that good stuff. If you're a CNCF project, then you can make use of our technology for free. We have a trial on the marketplaces, so go fill your boots and give it a shot. So thank you very much.
Awesome. Thank you, Ashley. Do we have any folks from X-Matters? Do we have any folks from X-Matters on the line? Okay, we're going to go to Humio.
Yeah, hi. Good afternoon. So you're developing applications in the cloud. Shouldn't the logging platform also be cloud native as well? So Humio is 2.5 years old, cloud native logging platform based on real-time streaming of the logging data, giving you real-time queries, dashboards, and alerts. Index free as well, so you can search any structured or unstructured data and get answers within a couple of milliseconds of that data coming in. And we got folks like Starling Bank, born in the cloud, running everything through Humio. So try it out. There's a free trial online. You can get access to it and see if it works for you for logging in the cloud. Thank you.
Awesome. And also nice new logo, I believe. This looks different to
yeah,
the usual one.
slight tweak of it, exactly, yeah. So that's seriously
Very nice.
funny. You raise another 20 million and you can tweak the logo a little bit.
Congrats. Okay, and Intel.
Hi, this is Anurag here. I work on edge computing. It's a nice project. A lot of it in open source domain also. It's called openness. Essentially, the idea is how do you bring edge computing closer to the telco network? And the idea is like cloudlets. So it's less of fog computing, which is in the devices, as you see. Sometimes people call it far edge. But more on the access network side, how do you merge edge computing with customer premises equipment, edge computing with various base stations, gateways, etc., and also in the network core network, etc. So how do you deploy applications, your cloud native applications, close to the user, where you have lots of problems already solved there, identity problems or latency problem, at least addressed to a great extent, etc. And then all about workload convergence. How do you bring together all three kinds of workload, as we call it, the IT workload, the cloud, typical cloud workload, the acceleration, what we call OT workload, and the networking workload. So how do you bring that together? So that's a very exciting thing happening, and a lot of good work being done to warm up the telcos to that, and how they want to create a telco edge cloud to deploy user applications.
Awesome. Thank you, Anurag. And yeah, thank you to all of our sponsors for this evening. I'm always looking for more people to get involved with this meetup. So if you go to my blog, oyshell.com/cloudnativelearn, you can sign up for a speaking slot. I think our next speaking slots, maybe we have a couple towards the end of the year, but mainly they're at the beginning of next year now. So please plan ahead and sign up. I really welcome first-time speakers, people from underrepresented groups. Just feel free to put yourself forwards. You can also sponsor our events and support the group. You can join the Slack group, and you can also catch up on all of the past meetups that we've run for the last nearly 3 years now. In fact, I think the very first one was July 2017. So this might be our 3-year anniversary meetup, which is pretty cool. And with that, I'm going to hand over to our first speaker. So I will stop sharing my screen. Thank you for the applause, Ashley. And I would like Juergen to go ahead and take over. Juergen, are you there? Okay, there might be a technical problem on his side, so we're going to do a quick switch around, if that's okay, and ask Josh or Alicja, are either of you okay to present first?
Yeah, I can go first. I don't mind.
Go for it. All yours. Thank you,
Cool.
Josh.
Hopefully everyone can see.
Yeah.
Looks good.
Yep, cool. All right. So yeah, this is going to be a talk about serverless versus Kubernetes. I think I maybe gave away some of the points earlier on while we were chatting, but we'll see how this goes, and it should help kind of give a holistic viewpoint on all of it. A little bit about me. I've been working in cloud native consultancy for a number of years now, working with AWS and GCP. I've built systems fully serverless on Kubernetes. I've spent I paid a big blood debt, I'd say, on both, trying to get to terms with them. So a bit of a warning, there's going to be a lot of opinions, but they're based on my experience and experience of peers and colleagues. So some things you may disagree with. If you do disagree, feel free to tweet at me, comment, get in touch with me somehow, because that's how we learn. So today's takeaway, the idea is to give something around the decision-making framework of when to choose Kubernetes and when to choose serverless, and where the inflection points exist between the two. Like at what point should you be looking at one over the other, or that kind of thing. So this is maybe redundant at the Cloud Native meetup, but we'll try it anyway. So I'm going to give my definition of what I see Cloud Native is. I generally see it as a set of properties that a system should have. I really don't see it as a very particular tech choice. It's more about achieving a goal. So I think an important thing is it's delivered using outcome-focused methodologies. What I mean by that is it's not resume-driven development, but behavior-driven development and test-driven development, that you're focused on delivering value over chasing the new tech shiny, which, don't get me wrong, I completely get. I love doing it, but it's not what we're paid to do, unfortunately. Yeah, pay-per-use, so not big upfront costs. I mean, you get a lot of that with cloud anyway, but the idea is your cost should scale with usage, which brings a lot of nice FinOps style ideas to cloud native, where you can actually track how much every user is costing you and get to some nice points of, did this feature actually make us money, or is it costing us more money than it's worth? Rapid delivery, not long lead times. I'm a big believer in the 4 DORA metrics and the State of DevOps report, and trying to work towards those as good heuristics for how you're going. Built to scale. And I think one of the things that sometimes get lost is this is scaling up and down as well. Scaling to 0 or near 0 allows you to do that kind of pay-per-use, but you also need to be able to scale up on demand, which I think we still see quite a lot, where you know, websites get hugged to death and all that kind of thing. It's still a big problem. Adheres to the 12-factor manifesto. I do think they're generally, that if people haven't read it, you can Google it. It's just got like 12 kind of basic kind of ideas that you should be doing if you're trying to do software development kind of with a modern approach. And I do think it is really important. But at the end of the day, cloud native is about value delivery, to me at least. But how do you deliver business value fast? Very much, you know, lean startup, Eric Ries, that kind of idea of how do you build, measure, learn, how do you determine what value is, and how do you go after it, and how quickly can you capture it, as opposed to any real technical choices you make along the way. So what is serverless? So I think I already talked about this a little bit in the preamble, but effectively, serverless is not Lambda. Serverless is the Google term to a degree, is no ops, but it's effectively paying a lot of pain away. I'm mainly going to be talking about Lambda today, but that's purely because I need to restrict it somehow. It's the most famous functions as a service offering, but I'm not saying that Lambda is what serverless is. Lambda is a tool within a serverless kit. And Lambda being the most mature and it being around since 2014, it's a pretty good point of reference to use. Kubernetes, again, I assume most people on the call know. It came out of an open source project out of Google. It actually came about around the same time as Lambda, so they both came out in 2014. There's been managed Kubernetes offerings on GCP since the end of 2014. I'm going to use GKE as my example for a few things, because in my opinion, it's the most mature offering of a managed Kubernetes offering. So I'm using the most mature function as a service offering, the most mature Kubernetes offering, because I think that gives the fairest comparison. So the origin of this talk was I overheard my CTO, well, my old CTO say this, and he is okay with me putting this up. I have checked. So he said this. I decided to take it completely out of context and run with it, because I'm that kind of person sometimes. And so we're going to take this as the idea and run through a scenario and see how it goes. Whether serverless would have been the right choice, containers would have been the right choice. It's loosely based on clients that I've had in the past and people I've talked to in the community and that kind of thing. So I'm going to set the scene a little bit. So we have a team lead called Beck. She's just joined a company called Quokka Inc. I lived in Perth for a long time, so people may have seen all the Quokka selfies. I just feel like it's fun to put in. And also I feel like it might make you like me a little bit more if you think of this when you think of me. But the idea is she's working on some greenfield new project, don't know whether it's going to have a lot of business value, and she's got a team of 4 developers under her. Not going to say test, dev, operations, because living true DevOps ideals, there really isn't that level of distinction, but it's a team of 4, which is a pretty well-fed 2-pizza team. And we want to be optimizing for flow, right? With a team of, especially with smaller teams, one person dropping out can have a significant impact on velocity. So it's important to make sure we are constantly optimizing for flow over short-term velocity. We need to ship fast. I mean, I don't think anyone's ever said they want to ship software slowly, but even so, it's a competitive market they're going into. There's competitors out in the field. They need to look to capitalize and capture the market sooner rather than later, otherwise they'll be left in the dust. We're talking lead times of a 1-line change hitting production in 10 minutes kind of deal. That would be where I'd like to kind of see it start out at, and work on that kind of as a fitness function around the system. It's a constrained budget, as in let's not throw all the money in the world at it. Let's not give finance a heart attack. Let's actually try and do this cost effectively and make sure we're using the money in the best place to get the best value, which is always a challenging thing to do. Limited cloud experience as well. So these aren't people that have been, using public cloud for the last 5 or 10 years. This is very much a case of they know how to spell AWS and GCP. They know how to run EC2. Like they may have done like a cloud migration, like moving EC2 machines over, but cloud native and that kind of architecture is still quite new to them. And in terms of goals from a user base, we're looking at like 1,000 users by the end of the first quarter, 20,000 users by the end of the year. That's kind of the projection for viability that the business has kind of set out. Multi-cloud, just because it's one of my favorite things to have a bit of a rant about. In this case, like the way I see a lot of multi-cloud stuff is sometimes you have legitimate reasons, but if you're like a startup or trying to innovate really quickly, going, oh, but we need to be multi-cloud is not really a thing. Like CEOs generally do get scared if you start whispering vendor lock-in to them, and there are good historical reasons for that, but they're not going multi-cloud. They have no real driver. There's no legal requirement. So let's focus on one cloud. I really do feel that generic cloud is bad cloud. If you start reducing all the clouds to their like lowest common denominators, you're kind of throwing away a lot of the value. Like if I'm on GCP and I can't use Spanner or Bigtable or BigQuery, if I'm on AWS and I can't use Dynamo or some of the cool technologies that really allow you to make good decisions and derive value, then you're going to be in a bad situation. So this is going to be done in a bunch of 6 rounds. So kind of going to go one by one through, compare the two, see which one seems better based on the constraints that we've already set. So I'm not trying to make unequivocal statements about which one is better. It's more about, given the constraints, this is kind of what you should be thinking about. And you can apply, the idea is you can apply your own constraints and come to your own conclusions. So when I'm talking about cost, I'm going to talk about cloud bill effectively, not all the therapy that you need to pay for when you've got a mountain of tech debt to pay down and nothing else. Pretty much just looking at cloud bill. So looking at Lambda, you get 1 million events free per month. That sounds pretty cool, right? Like that's a lot for free from AWS. What that turns out to kind of be is about 1,400 an hour, 23 a minute, an event every 2.5 seconds. Before I've actually had to pay AWS for the privilege of handling the events. If I'm building something greenfield and I'm getting 1 event every 2.5 seconds or 1,400 an hour for like a general web SaaS kind of product, to me, that's a champagne problem, right? Like I'm very happy at that point. Like if I've got to that level of viability and that level of usage, I've started to hit product market fit and I've started to accelerate. But just in case people are thinking, oh, well, it's AWS, they want to get, or a cloud vendor, they want to get you in and they want to kind of get you invested into the system because then they really hit you later, right? I mean, for the next million events, we're talking 20 cents. You know, it's still cheap. Obviously, the compute side is not included in that, but still, like, you get a lot for free with AWS, or, you know, your cloud bill is sub $100 for running a production system. It is impressive stuff. And one of the cool things is, if it ain't being used, you ain't paying for it. So, you know, you can run up test environments, dev environments. You only pay for the usage. So as you scale out with more developers, the cost doesn't increase. It increases sublinearly with developers, which is an awesome place to be, right? We always want to be sublinear on cost. I imagine people have come across Corey Quinn in the past. He's a very loud person in the cloud space. This was taken from one of his newsletters a long time ago, that Kubernetes is named after the Greek god of spending money on cloud services. So, you know, he's a professional satirist, I would say. So, but what does that actually look like when we actually look at things? So if you take a couple of node cluster, we've got 4 CPUs, 15 gig of RAM, like that's kind of like a minimum size, $200 a month per cluster. It's not stupid money. When you compare it to developer rates and everything else, still not that much in the scheme of things. You know, but how many clusters do I need? You know, if you're trying to optimize for speed and flow and velocity, this kind of feels generally good. So 1 for production, 1 for test, 1 per developer as well. I like that idea. You know, looking at $1,200 per month. Still, you know, still not huge, but a lot more than 0 or a couple of dollars or $100, right? I mean, that's money that could be invested into other tooling or, you know, other things to help you move along the way to getting to where you need to be. If anyone's wondering why I haven't talked about storage or database or anything else in terms of cost, because I feel you're going to be using them either way, hopefully using the same ones either way, in which case that cost part I would say is moot. But just because Hacker News is a wonderful place, but I read on Hacker News that Lambda costs 5 times as much as ET2. I mean, yeah, technically in a lot of ways they're right. You know, it does cost for every kind of unit of compute, it costs more, but that's based on the assumption that you're using it constantly. I mean, you know, when you look at this kind of thing, obviously there is at some point for some number of requests that you're going to be able to handle on Kubernetes cheaper than you can serverless. It's like millions upon millions of requests a month. It is like it's seriously high numbers. Unfortunately, I didn't have my speaker notes. I think it's something like 20,000 requests a second kind of thing, like with thousands of requests a second, not the 1 every 2.5 seconds, but to get that kind of cutoff point on the back of envelope, it is significant numbers. Like it will take you a while from a greenfield to kind of hit that kind of level. So kind of taking it back to what we're talking about here. So they've got a constrained budget. They're trying to go for, 20,000 users. So we're not talking in the millions of events here. We're talking in the, hundreds of thousands a day, maybe, if we're lucky. I mean, I'm going to give this to, I think the winner is serverless right now. Like it will be cheaper to run and we'll give you more money to put elsewhere. But obviously there's a caveat for now. There is at some point that Kubernetes will be cheaper to run than serverless. But when you take the cost of the maintenance and the man hours that has to go in to be able to deliver it, where that actual inflection point is probably a lot further and a lot more requests than you actually think it is. But this is why we model these kind of things and figure them out. So move on to round 2. I'm kind of looking at request response times and scalability on these. Again, obviously there's a lot more to talk about performance, but these 2 are kind of the big ones. So when we talk about request response, I think the important thing to consider is it's not just, is it faster, but in terms of user empathy, like what is fast enough, not what is the fastest, because those are 2 very different things and it gets expensive, right? Like, I mean, I took this photo of my wife the other day when her laptop started lagging out. People get angry when stuff is slow. Like we all know that there is, things from Amazon that point out that, for every 100 milliseconds of latency, they lost 1% of sales. Google have, if search results are slower, then they lose people and all that kind of stuff. So latency does have a real impact. But what's an acceptable latency? Like, what is acceptable for what you're trying to do? Because, you know, for a lot of services, you know, half a second's probably fine, generally. I mean, I think the real way to kind of do this stuff is to come up with a hypothesis, right? Like, what do I think is going to be the latency? What's going to be the impact of latency on the business metrics I care about? So something like this. I don't think this is amazingly great, but like, if the 99th percentile of response times goes over 300 milliseconds, I don't think it's going to cause conversion to drop more than 1%. And for the cost of engineering to get it under 300 milliseconds or some, you know, some higher guarantee, get against 1% of conversion, do I care? Yes or no? I don't know, but this is the kind of way it should be looked at, right? So to talk about kind of the elephant in the room when it comes to response times with serverless, I mean, it's cold starts, right? Like everyone talks about them. AWS put a lot of investment into trying to pay them down and all that kind of thing. I mean, for anyone that isn't familiar with the cold start idea, this is taken from some reInvent deck. The idea is that when you boot up a Lambda for the first time, there is some amount of latency while everything gets orchestrated. And then when your code starts, you've just got warm starts. So the idea is if you reuse the same Lambda or function invocation, it's a lot quicker. Generally nowadays for most things, it's like a cold start to a warm start is 200 to 300 milliseconds, give or take. You can optimize it, but that's kind of where you're looking at in terms of time. If you need sub 200 milliseconds for like 99% of requests, then you should probably be looking towards Kubernetes. I used to have need there until provisioned capacity came out on Lambda, which does kind of change it, but you're starting to throw away quite a lot of the niceties about Lambda, and still the provision capacity doesn't scale. You have so much warm, but you're still going to get cold if you have really bursty stuff and that kind of stuff. So you still have to think about it. You can't really dodge it, and Kubernetes gives you some nicer ways to handle that, and you can really handle stuff a lot quicker. Like I've run systems where on Kubernetes, so this is the spec I talked about before, the 2-node. Like I've run 2,000 requests a second, sub 35 milliseconds, you know, 99.9 percentile with room to spare. Like we were quite happily handling that. So, you know, if you've got a system that needs these kind of things, then, you know, Lambda's probably not the right fit at that point. But for a lot of systems that we build, you don't need this. You might like to have it, but it's not a need, right? So just going to quickly talk about some scaling issues that I've seen in the past, because they're fun. So a lot of things scale until they can't. Generally, when you look at things, you've got what's in your sphere of control and what's in your sphere of influence. And then in the worst case, you have something that doesn't fall into either of those two spheres. So I had a case where I had a downstream system that I had to use that was maintained kind of as a legacy system. It could handle 10 requests a second. So we're really talking like the Aston Martin of systems here. And, you know, I built up a serverless architecture, built up a serverless system, got some users onboarded, and everything set on fire, right? Like it happens. But, you know, unfortunately, a lot of the scaling limits on our systems are not in our sphere of control, they end up in our sphere of influence. So yeah, cool, you can scale, but, you know, often the bottleneck is not within your things. If you pick either Kubernetes or serverless, you're probably not going to be the bottleneck on scaling, something else is, right? Another example, I have a friend who works for an app development company. The kind of second icon on the right, he built that app. He got an Apple Design Awards, and nobody accepted 140,000 users to all of a sudden appear on the app during WWDC or whichever Apple conference it was, right? He was running fully serverless, and it did not cope. Like the unknown limits. Like you can know what you've seen before, but he all of a sudden discovered because of this that there's such a limit on GCP, and there's equivalent ones on all the other clouds. Cool. You don't know that exists until you hit it. Like no one knows that exists until they hit it, right? And they'd never hit it before, but all of a sudden that happened. It didn't scale they had a 4-hour outage, and he spent the next week with doing manual remediation to kind of fix everything up. So understanding what it is you need to do in order to actually scale and properly testing these things is important. Like, you know, it's important to have visible metrics aligned with business goals. So back to kind of the hypothesis I had, so understanding what the business impact of certain things is, as opposed to just metrics for metrics' sake and just going, well, my CPU util is at 80%, or my CPU util is at 95%. Does the end user know? If not, then okay, well, it's a problem. You probably want to look at it, but it's not impacting anyone. So, you know, having that kind of trend, that visibility is really important. So, you know, with the hypothesis, I think 300 milliseconds for, you know, 99% requests is probably going to be fine for this. We don't think it's going to impact business metrics, but, you know, we can test for that. And with these kind of users, so, I mean, people are probably expecting me to say serverless there. You can achieve it with either. Like, there's no restriction either way. So from a performance angle, you can pick either one, and either would be fine. Neither one is better than the other based on the constraints. So security, you know, everyone's probably seen the shared responsibility model in terms of paying away the pain of handling a lot of security things. Generally, if you can kind of shift that orange section higher up or replace other cloud provider there, generally the happier you are, right? Like, kind of the inconvenient truth for a lot of security teams is that like the cloud providers do security better than you do, and will always do that. And it's just the nature of scale and amortized costs. Like, they will be better. I mean, do you remember when Spectre and Meltdown came out? Because I sure do. I was running on-premise infrastructure at the time. One of my colleagues stayed up till 4 a.m. fixing everything. Restarted all the servers, applied the patches. He thought everything was good. I get in the following morning, half the servers aren't working. You know, I get all the calls. I don't know what he's done. It was pretty awful, right? Like, what happened if Spectre 3 happened right now? Like, everything I've built in production for the last 3 years, I don't mind. Like, I don't have anything to do, right? Like, building on these kind of, especially serverless platforms, like, I don't care about the compute anymore. So this is pretty cool, right? Like, I don't have to do anything. Like, my favorite kind of security problem is someone else's, right? I mean, I don't want to have to deal with those kind of things. I mean, I will if there is a problem, but if I can pay someone else to go and handle this as just part and parcel of what they're doing, then that's awesome to me. Like, the best case is maybe I have to, you know, so if I'm running Kubernetes, maybe the best case is I have to kind of like bring a new node pool in and migrate everything over. That's pretty cool. Maybe I have to do like a Kubernetes upgrade because there was a CV on Kubernetes on the Kubernetes control plane. So now I have to do that as a priority and get that tested. Maybe I have to bring out new Docker images, new VMs. There's all these manner of things I could have to change, right? And I think one of the things is we don't want heroes in the teams. Like, heroes, sometimes they're required, but it shouldn't be the way to go forward. Like, heroism leads to burnout. Having to stay up until late in the night fixing things, being woken up at 3 a.m. This is how one of the real contributing factors to burnout in teams. So if we can avoid it, that's awesome, right? If it's not our team that has to suffer the burnout, I know that kind of sounds a bit selfish, but still, like, AWS have, you know, round the clock support, or the cloud providers, they can manage things better and make it so no one has to do that. So again, kind of coming back to a team of 4 with limited cloud experience and ship fast. Yeah, serverless wins this outright. Like, there's less for them to worry about from a security angle. Therefore, it's easier for them to do security and they can focus on other things. Round 4, operations. So monitoring, like, monitor all the things, you know, put everything in, everything everywhere. Just get that notification fatigue. Who knows what's actually going on? Like, what's the business value in keeping virtual machines alive? It's about what the impact to the end users or the consumers of the system is, not necessarily whether a virtual machine has died. Like, you know, if you've got single points of failure, then it's quite easy to have everything go down. Like, in Star Wars, they attacked the Death Star, and that was a single point of failure, although they had to do it twice. You know, but they could never take on the entire fleet of Star Destroyers because, you know, there's too many of them, right? So if we think about serverless a way of like the most minimized blast radius you could ever have, because all the Lambda invocations automatically get spread over lots of compute over Kubernetes, then blast radius is smaller for something going wrong. Like I don't want like my production system going down because a virtual machine died or something went wrong, right? Like I do think at the end of the tech apocalypse, there'll be Kubernetes operators sitting around sharing horror stories. And there is a great resource of Kubernetes failure stories for people looking at it to understand what other problems people have hit and learning from other people. There is not a serverless equivalent I've ever seen, partly because I don't think there's as many ways to trip yourself up, although there are some. Like, how do you get valuable monitoring? I just put this in because there's always one Warhammer 40K nerd in the group, which is awesome. But effectively, you want to introduce chaos into the system and figure it out. Like, don't just put monitoring in for monitoring's sake. Introduce chaos engineer and figure out what monitoring is really valuable to you. Again, to bring it back, we've got a team of 4 with limited cloud experience, want to ship fast. Yeah, I'm going to go serverless. Like, haven't talked about service meshes because I've had to cut the talk down a little bit and I'm still kind of running close. But at some point, service meshes will have a lot of value to your business. It ain't in the first 6 months you've started a new project. It's, you know, years down the line, and you have to be at some level of maturity for it to be value. But eventually you could get there, right? If it grows to the point that it's valuable. So potentially Kubernetes could become better operationally in enough time and at enough scale. Learning curve. So based on my experience helping, you know, new teams adopt serverless and Kubernetes, I think knowing enough to be dangerous. I mean, I've delivered 2-day Kubernetes training courses where people felt comfortable enough to kind of go on themselves. I think for serverless, you're probably pretty close as well. Couple of days, comfortable in production. I'd say probably a month for serverless and 3 months for Kubernetes based on my own experience. Rate of change for serverless, you get small changes throughout the year. Reinvent for Lambda is generally the big releases that make the big changes. Obviously Kubernetes, you get every 3 months, and cloud providers update when enough people complain, or you know, when the version they're supporting is their main version goes out of support and all that kind of thing. So if you want the big new shiny bells and whistles from KubeCon, you can't run managed Kubernetes a lot of the time. And if anyone's ever tried to run not managed Kubernetes, you understand how much of a pain that can really be, right? Yeah, I mean, never discount under engineering a problem. Like, the simpler you can make it to achieve your goal, the better off you'll be. That's just kind of a pretty good rule of thumb, right? I mean, if we take a serverless MVP, probably built out of those kind of 5 services on AWS. I took the equivalent AWS services for the Kubernetes example, but if I had to contrast and compare those services, so S3, Lambda, API Gateway, DynamoDB, and CloudFront versus those, I think the serverless ones are much easier to pick up. There is less to pick up to become proficient with them than picking up EC2 machines. Like, the amount of serverless devs I know can go and write Lambda all day, but you drop them into a shell in an EC2 machine and they just don't know what to do anymore. But I think that's a good thing, that they don't know how to do that anymore. I like it when devs kind of don't know how to SSH into things, because they shouldn't need to. And if I can avoid them having to do it, then they're spending their time on other things. Again, bringing it back to kind of the constraints we're talking about. So team of 4, limited cloud experience, ship fast, has to be serverless on this one. I really think it will allow them to deliver value faster and get something out the door within a week or so. I think Kubernetes, you're looking at a few weeks for a new team to really get a handle on it and feel comfortable pushing something into production. Round 6 dev experience. This is probably one that I generally find people have more opinions on than the others. I think for dev experience, it's more cultural and technical. Generally, I care more about how to enable developers with sandboxes for experimentation, that things are done test-driven, that you're using trunk-based development, that you're running continuous deployments, which I understand for a lot of people running older systems is like some nirvana to reach. I really think the only way to get there, having worked bringing legacy systems to a continuous deployment model, is just do it and feel the pain and just take the pain and figure out the way to make it happen, right? I really don't, for dev experience, like, I've seen equally happy teams running Kubernetes and serverless from kind of scratch. It was more around the cultural stuff and the ways they dev'd that really made the difference, not about the technical choice. So if we kind of look at final scores, so serverless 4, Kubernetes 0 with a couple of draws in there. So for me, the winner for like a greenfield system where you're trying to iterate fast and try and capture market and discover things and validate your product market fit, then serverless is a wonderful way to do that. Maybe Tim was right, but I will never tell him that to his face, and I've refused to. I think the way I kind of see it is serverless when you can and containers when you must, right? Like if you can go serverless, you're probably going to have a good time. If you have certain constraints that push you to containers, then cool. You're still going to be in a better position than a lot of other systems. You're still going to get a lot of the benefits, but the amount of effort is going to be quite a lot higher. And I think it's make sure you're understanding those kind of inflection points and understanding where the work is being and time is being spent to understand how the tech choice is impacting the team. It's important to have that kind of visibility into the happiness and the velocity and all those kind of things. But generally, if the dev team is happy, then things are generally going well. Like make data-driven decisions on these things. Like people have asked before, like when Kubernetes, like super high request volumes, super low latency requirements, if you've got long running workloads, if you've got existing brownfield systems, if you need to run multi-cloud for regulatory reasons or something like that, or you're trying to move some application from on-premise to the cloud, Kubernetes is a wonderful solution if you have those requirements. If you don't have those kind of requirements, then serverless is probably going to suit you better. Again, just to bring it back to kind of the team we're talking about. So, a year later, they've got 30,000 users. They got more than they thought. Now they've validated their product market fit and got an idea of request volume. They're now looking at migrating to Kubernetes, whether they're going to use Knative or Kder or OpenFaaS or something to make that migration easier. But they validated the fact that they've got a big enough user base that Kubernetes is going to be better for them in the long term. So they're starting to make that migration now, rather than do it up front and potentially never get the validation that they needed. And at the company, all greenfield development is still serverless by default. Like just because one team's made the move to Kubernetes, I still think it's better for new teams to still pick up serverless and get moving faster, because you retain more agility by going serverless and you can move more with the business in terms of new requirements and moving fast. And you don't have to spend time worrying about virtual machines and all the additional stuff that comes with that. So that's kind of the end. I think I only ran a couple of minutes over, for which I apologize. If you want to argue with me, share opinions, chat to me, anything like that, catch me on Twitter. I did leave it on kind of all the other slides, and there were a few tweets flying around. But hopefully you enjoyed that.
Awesome. No, that was fantastic, Josh. Thank you so much for sharing. And I'm really interested to see if anybody has changed their mind now, because when we polled earlier, it was something like 45% thought that Kubernetes should win. And then as you've laid it out, it's like serverless is the winner. So if anybody's changed their mind about this or has opinions, then please put it in the chat. There's a couple of questions in chat as well, which I'm going to leave you, Josh, to follow up on, because I want to hand over now to our next speaker. So Juergen, are you ready? He had a couple of problems with Zoom earlier, but
this time I think I can
manage.
Can you hear me, and can you see my screen?
Yeah, all looks good. Over to you.
Okay, good. Sorry for the inconvenience earlier. My Zoom completely froze. But yeah, thanks for having me here. And I want to talk a little bit about overcoming more of the organizational scalability issues in the Prometheus ecosystem that we have seen working with a couple of customers using mostly our open source project called Captain. I personally work for a company called Dynatrace. We are originating from the monitoring space. We are now a software intelligence solution with AI baked into our product. And But today I won't talk about Dynatrace. I want to talk a little bit more about Captain, or how like we see the scalability issues, and how what are the major blockers, and how to overcome them, and how then this open source framework could come into play. Well, let's start with what I actually want to have, and this kind of relates a little bit to the question we had earlier in the poll, where like, how are you creating all these dashboards, alerting, the monitoring rules, scrape jobs, all these kind of things in your Prometheus ecosystem? How are you creating this? And actually, most of you are using some kind of automation, which is great, but actually I think everything should be automated, because if you change something, you don't want to go there and change all the dashboards to kind of, or you have to maintain them. Everything, if something change, there should be like a chain of commands that will also update other dependencies, like scrape jobs, alertings, dashboards, and these kind of things. So basically, we want to have this automated. And I will talk a little bit about 3 challenges, what we have seen working with customers. And I've also written a blog, so most of the parts I talk about today, you can also find in on the blog here. I think I can also share the slides afterwards. I've just put the link in the chat. So if you want to take a look, then you can also click on those links that I put in here. So I will talk a little bit about the challenges, and then a little bit about how this open source framework could solve those challenges as well. But of course, I will also provide solutions early on when I talk about those challenges. So if you want to build it yourself, feel free to do so. So let's start with some basic building blocks that we most often see, and it's like very, very simplified. So I would hope that we can agree on, and there is no serverless in this presentation, but yeah, we just talk about like Kubernetes, Prometheus, these kind of ecosystem. So we have a couple of application clusters. We might have a multi-cloud scenario, hybrid cloud scenario. We just have a couple of Kubernetes cluster. Most often it's more than one. So we have all our workloads running there. They have some kind of endpoint where they expose the metrics. Prometheus is fetching all those metrics. We have some Grafana on top of this, using data from Prometheus. We have a couple of folks managing our Grafana. We have some managing Prometheus. And then, of course, we might also have a couple of Prometheus instances. So today, I won't talk about scaling Prometheus from this technical point of view. There are other projects like Citus and Victoria Metrics, and there are a couple of those out there that you Prometheus at scale from a technical perspective to have high availability, these kind of things. What I want to talk about is all this configuration that is needed for your Grafana from Prometheus to really get value. And Josh was talking a lot about getting value from either serverless or Kubernetes. And I also want to talk about getting value from these kind of monitoring and dashboarding solutions. So first challenge that we have seen is that there is no central configuration management. A couple of companies, they were writing the scrape jobs and recording rules, alerting rules, dashboard configurations, and they're applying this without a lot of automation. They're applying this to Prometheus and the alert manager and the Grafana installation, and they are not really sure which kind of configuration right now is really the one that is applied in their production environments. So they might drift a little bit out of sync. So of course, they want to have it version controlled and to keep in sync between what they think is running in production and what is really running in production. So one approach is to use the GitOps approach. Put everything, all the configurations you have, put it in the Git repository, and you have an operator running that is basically synchronizing the Git repository to your Prometheus with the alert manager and your Grafana installations. And you will never touch your production environment manually. You won't touch it anymore. So it's really that you only commit to your Git repository, and in the GitOps fashion, once this new PR basically is merged, the operator will apply it to your production environments, so there are no manual edits anymore needed, which is a good thing. Next thing is that it's not only one scrape job, but it's a lot of them. It's a lot of alerting rules. It's a lot of dashboard configurations. You might have different ways how to write them. So you will spend some time, or some folks at your organizations, they will spend some time writing all these kind of things. Of course, what you want to have is some kind of automation, some kind of code generators to use. And there are a lot of code generators out there. And I actually put a couple of them at the very end of the slide deck. And if you have more code generators that you are using and you want to point them to me, I would be really happy if I get some more input here, because there are already a couple of those out there, like Prometheus, Graphonet, based on JSONet. So there are a couple of those that allow you to put in some kind of, let's say, parameters, and they will then generate all the configuration for you. So no need to write actual configuration files. Cool thing. But what we have seen is that they are not everything in the Prometheus ecosystem is based on the same kind of configuration file. So for Grafana, you are using a different configuration language than you would do for your scrape jobs or alerting rules or recording rules. So it's basically, one problem is that those configurations, they drift out of sync between the different kinds of configuration files. The reason is that, as I said, they are in different formats, and there is no common input that they are using. So what we have seen is a good approach to base everything on well-known concepts from the site reliability engineering community, base things on service level indicators, service level objectives, error budgets, these kind of things. They are, I would say, well known, they are well understood, there are books on it, and from those concepts you can generate a lot. So what we kind of evangelize is define what you want and then generate the rest, and do not define how it is done, because it changes quite frequently. There are Prometheus versions every couple of months, I guess. There are also Kubernetes versions every couple of months. So all these kind of things change a lot. And if you just have to change, if you have to change all those code generators, then it might be kind of a lot of work. But if you have some automation tool that takes those SRE concepts and put it as probably as an input for those code generators, and takes all the work and does it for you, that might be a good thing. So with this kind of mindset, how you can overcome some of those challenges, I want to introduce an open source project called Captain, that you can use to automate the configuration of Prometheus and Grafana. But actually at its core, Captain is an control plane for continuous delivery and automated operations. But I will show you how you can Captain to also kind of satisfy the first goal. And in a nutshell, in one sentence, Captain is an event-based control plane for continuous delivery and automated operations. So you can have Captain living in your Kubernetes cluster, or you can have actually Captain living on some kind of small Kubernetes distribution where you just want to have your control plane up and running. If you don't want to run Kubernetes, you can still have Captain running somewhere on some kind of Kubernetes runtime, let's say. And it's in control plane in the sense Captain is receiving events, and upon these events is reacting and is doing some computation and then generating other events and sending those events. So it's basically receiving events, doing some logic, sending other events to different other services that again respond back to Captain, and Captain is controlling the workflow. So to make it a little bit more concrete, what Captain is doing, it's basically integrating with a lot of services so you can automate a lot of things in your Kubernetes environments. So let's say Captain is integrating with your continuous delivery tools. So once Captain is triggered to deploy some new microservice version, Captain can reach out to the deployment tool, trigger the deployment. Once the tool is finished, it will receive back the event that the deployment is finished. Captain can then trigger the testing tool. Once the tests have been finished, it will tell back to Captain, tests are finished. Captain can then trigger an evaluation step upon those tests based on SRE concepts or files that are generated of those SRE concepts. Can trigger the evaluation, can generate a score, and then Captain can either decide if it wants, if it should be promoted to the next stage or not. So with this, Captain really interacts with tools for continuous delivery, test automation, evaluation, but also Captain can interact with tools for monitoring and tools for dashboarding. So when Captain is told to configure some monitoring providers, monitoring tools, Captain will reach out to them and do the job for you. Why does it scale better than without using Captain? Because Captain has already some built-in capabilities, generated some dashboards for you out of the box, and also will generate those dashboards based on some well-understood concepts of service level indicators and service level objectives, which I will come to just in a minute. So what are service level indicators and service level objectives, and why am I using these terms? So first, we are taking these terms from the SRE community, and I've also put a link to a great YouTube video at the bottom of the slide. But for the next couple of slides and for this use case, what is really important are what is the service level indicator? And that's basically some metric you can measure, like an error rate of a login request. And the service level objective is then some objective, some target based upon the service level indicator, like the login error rate must be less than 2% within the last 10 minutes. So it's just one objective for a microservice or for a service, basically. So we can use these concepts. And yeah, a couple of those, they are already included in Captain. So if you don't have to write them, you don't have to know how to calculate these kind of metrics. So like the red metrics, they are quite, I would say, more or less standard metrics that you're using for the response time, the error rate, and the throughput. This is included already in Captain. So each time you are managing a service with Captain, you already get these kind of things out of the box. So how can we create now dashboards and alerting and scrape jobs based on these kind of things? First, in our SLI file, we just define the indicators like the error rate, the number of database calls, the response time, the 90th percentile, whatever we want to do. On the left-hand side, like the key here is just the name of the SLI. We would also define the actual query, the prompt URL, how to fetch this SLI. But we can reuse then the name of the SLI quite easily in our objectives file. So we can write very easy objectives like the error rate has to stay within or has to be lower than 1%, or the number of database calls has to stay within an increase of 2% to the previous evaluation runs, or it has to stay within 10 database calls. So there are a couple of possible ways to define really an objective, and based on this, we can define basically the scrape jobs, because we already have the queries, and we can also generate the dashboards and the alerts. So we can automatically generate a couple of things. How are we doing this? Captain has its CLI, and also API. So either way, you have both versions. Let's say both versions to communicate with Captain. They are sending a cloud event. A cloud event is also a CNCF project. And it's basically an open standard how to define events within your environments or ecosystem. So we are using cloud events. We are sending a cloud event to the Captain control plane. It will distribute to all the services that are connected to the control plane, and they will then integrate this cloud event and will do the execution. For example, generate dashboards, generate alerting rules, generate the scrape jobs. So with this, you can make sure that the configuration between Grafana and Prometheus stays in sync, because you generate everything based on one configuration file. But you can do more. Since you have defined these SLIs and most importantly the service level objectives, again, it's the same example on the left-hand side, you can also use this when it comes to continuous delivery. You can do continuous delivery with Captain, but you can also think about a small part of your continuous delivery where you want to validate the quality of an artifact. So you could use Captain, again, the CLI or the API, to just send this event to Captain to evaluate some service for the last 30 minutes based on this service level objective file. And Captain will reach out to the data provider. So we already have integrations for Prometheus, Neoload, of course, Dynatrace, but most importantly, you can exchange those quite easily via the Captain uniform. And I was talking earlier today, maybe just a quick side note, I was talking earlier today to some folks and they reminded me about the explanation about the term Captain. I'm not a native speaker, I'm from Austria. We speak German here, and Captain should actually be the pronunciation of a captain of a ship. So, but for us, if we spell it this way and say it out loud, it kind of sounds like this. So it's not kept in, but it's really a captain of a ship. And with these terms, with these nautical terms, we also have like the shipyard file, which defines the environment of a captain. We have the lighthouse, which is basically telling us if the quality is fine or not. It's giving us the right direction, and these kind of things. So I just wanted to elaborate on this. So Captain will then reach out to data providers and score the build, and then give back a total score, either passing or might also be failing. So you can use the Captain quality gate in your whole CI/CD journey, basically. So how to get from 0 to a fully managed or fully generated Prometheus and Grafana dashboard. So the first thing is you would tell Captain to create a project. That is basically a project is this collection of services. Like a project could be your web shop, and the services could be a login service and a shopping cart service and a search service and these kind of things. So based on a shipyard file that defines these kind of stages with different deployment strategies, different stress test strategies, Captain will set up already the environment for you based on the Captain's uniform that defines the tool set. So in this case, the tool set could be Prometheus for monitoring. And Captain will store all the configuration file in its internal Git repository, following this GitOps approach I was talking about earlier. You can also link the internal Git repository to GitHub or GitLab or whatever you want to, so you can also modify it there. Next part would be to onboard services with help chart for deployment and with the SLI and SLO files that I showed you earlier. So Captain can manage the service and knows about the right quality that you want to emphasize for the service. So with this, giving Captain the help charts, the SLI files, SLO files, Captain can make sure to be able to deploy it, but also to validate the quality and to make sure to not allow something that is not satisfying this quality criteria to be pushed into your production environment. And now Captain can also be used to configure your monitoring solutions. As said, we have different integrations here. So for configuring Prometheus, Captain can directly reach out to your Prometheus environment, set up all these scrape jobs for the onboarded service, and also for based on the SLI and SLO services, and also start to configure the dashboards in your Grafana environment based on the declarative description. And then you can use Captain to basically deploy your artifact. So I would just try to sketch here on this one slide how Captain is also do the deployment of artifacts in your Kubernetes cluster. First, you're telling Captain to start a deployment. So Captain will basically update the Helm chart in the Git repository. Captain will do a blue-green deployment if it's defined this way. It will create a second set of pods based to the first one. We'll route the traffic to the second set. Captain will automatically reach out to the testing tool based on first the Captain's uniform, where you define which testing tool you want to have, and also based on the test files that you added to the Git repository. So Captain will start the tests. Once the tests are finished, Captain gets an information, tests are not done. Captain will start to reach out to the Lighthouse service to trigger the evaluation. The evaluation is done, and Captain will decide if it should be promoted to the next stage or not. And basically, each following stage will do exactly the same. So it doesn't matter if you have like a 3-stage environment or a 5-stage environment or 2 stages, it's always the same approach: deployment, testing, scoring, and then deciding if it's promoted or not, if it should be rolled back or not. So if there are no tests, Captain can skip some parts, but baked into the solution, it's always the same, same approach, I would say. So in this case, everything's fine, and Captain will deploy it to production. If something goes wrong, Captain can also be notified about problems, and then the Captain control plane can reach out to different automation tools like Ansible or ServiceNow or I think Rundeck to trigger some remediation actions, and then afterwards, again, evaluate the quality of the software, the quality of the microservice, to make sure that the remediation action actually did the right job. So it's not only for the deployment, but also once you're already in your operations, Captain can make sure that your applications, let's say, stay alive in your production environments, or can just roll it back, toggle a feature flag, or these kind of things. So how have we built this integration? It's basically, we have the Captain control plane, and then we have a couple of services that are contributions to Captain that extends the Captain ecosystem. And I've just listed 3 here. So we have the Prometheus service that is responsible for configuring Prometheus. We have the Prometheus SLI service, which is responsible for fetching all the metrics from Prometheus. And then we have the Grafana service responsible for doing all this dashboarding. So with this, I'm listing here a couple of resources. First, the blog that also gives more details on some parts. Then a couple of code generators that we saw folks are using to basically do a couple of their automations. And a link to the red method I was talking about earlier. So if you have more automation tools that you are using, I would be happy to list them here as well. If you think Captain is something that you might want to use, feel free to reach out to us or check out the links provided here. And with this, I want to thank you. And yeah, I'm happy also to answer questions. I will take a look in the chat.
Thank you so much. Yeah, there's a couple of questions for you, so I can help read them out. How do you compare Captain pipelines with Jenkins pipelines?
That's a good question. So first, in Captain, we call them delivery pipelines, but it's basically no pipeline code you have to write. In Jenkins, usually you write your pipeline code. In Captain, you just define in the shipyard file what you want to have. It's basically a shipyard file for a 3-stage environment. Let's say you have dev, pre-prod, and prod. You want to have a blue-green deployment strategy, and you want to have performance tests in all of those 3 stages. It's like 10 lines of YAML code, because you just define what you want to have. And in Jenkins, you would have to write a whole Jenkins pipeline. You would have to figure out how to do blue-green deployments. So it's really a different approach. We are basing everything on events, receiving events, sending these events to external tools, while in Jenkins you would write your pipeline. And what we saw is Jenkins pipelines tend to be more monolithic. And in Captain, you can really break it down to smaller pieces because it's event-based, and all those smaller services, they just do their job and you can just react on those events.
Okay, great. Another question, how does Captain match/analyze the SLO and SLA parameters by analyzing the underlying toolset's data?
Okay, so if I understand it correctly, I'm sharing again my screen to probably be able, here we go, to show this a little bit. So the underlying data here, for example, so the underlying data would come from Prometheus, but in the SLO validation, we actually abstract completely from how we get this. So the error rate would be just some integer, and we can compare this integer to some criteria. So for this, we have those different kinds of services. We have the SLI service for each data provider, which is basically fetching the service level indicators and translating to the format that Captain can understand. So it's basically transferring whatever we get from this API call or PromQL query to some data we can compute on. So like an error rate would be a percentage, count of DB calls would be a number, response time would be also just a number. So we are transferring this, and in the SLO file, we can then guarantee that the error rate, whatever we define here, would also match the same if we change the underlying data provider. So they just have to be like, it has to be the same name, and then you can change the indicators from one tool to the other, if that answers the question.
Cool, awesome. I don't think there's any other questions, but if you do have questions, then please leave them in the chat or contact Juergen after this event. So thank you so much for our first two speakers. We're now going to take a short break, and we will come back in 15 minutes. So feel free to get up, stretch your legs, just, yeah, take a break. I'm gonna restart a timer so we know when we begin. And then I'm very excited to have Alicja with us in 15 minutes. Otherwise, I'm just gonna stay here and chat. So if anyone wants to chat to me, feel free. Hamad, yes, I'm doing very well. I'm doing well. I think we're all a little bit tired of being in lockdown, but otherwise good. I'm also very excited that we're gonna, one day when we come back to having face-to-face events, like I really miss seeing people face-to-face, and I like these events, but they're not the same as our face-to-face meetups. So I'm excited by that. Are you in your kitchen or background? This is actually my kitchen. People ask me quite often because I appear to live in a Shoreditch hipster coffee shop, right? No, this is actually genuinely my kitchen. I've said to people that when I move house, I have to take a picture of this and then use this as my virtual background, because now people are used to this as my background. Ren, magnet, or which one? Well, okay, it was actually Ren, but this is not an endorsement for Ren Kitchens. For one thing, they're not a sponsor of this meetups, but this happens to be a Ren Kitchen setup. Looks very neat, something like WeWork. Oh, thank you. I feel like that's a kind of compliment, right? It's like, yeah, very hipster coffee shop, exposed brick wall. When we moved into here, this looks like something from the 90s. I think the previous owner had gone to Morocco or something, and they painted everything yellow and red. So we kind of stripped this all out and redid it as a bit more modern style. But yeah, I do love this kitchen. Isn't it weird that like this is now the most important thing that you know, like you start to see people's backgrounds, you start to see people's, what their audio setup is, what their video setup is. It's really strange to me. I feel like people should actually talk to me because I feel like I'm just talking to a chat window. So if anyone wants to actually open up their mute and, or like unmute themselves and chat, that would be great. I guess people are feeling shy.
How do you find, like, I don't know if you can hear me or not, but how do you find like doing meetups kind of virtually in comparison to doing meetups in kind of the real world?
Very different. A lot more AV setup. So I'll give you an example. If you were on last month's meetup, you remember that one of our attendees, Kusho, played guitar for us during the break. And he was really eager to come back and play again. So I was like, yeah, that would be awesome. And they said, okay, but I want to use a backing track, which means I need to get a license from the publisher, because if I don't, then the video is going to be copy striked by YouTube, and then it get taken down. And then if potentially it will take down your whole YouTube channel if you get copy striked 3 times, I think. And I was just like, wow, who knew that that was a thing, right? You know, like I like doing these virtual meetups, but there's so many more little bits and pieces that, I don't know. What's your experience, Danny? Like, how do you feel about these versus
the real one?
Events?
It's really odd. Like, you don't get the beer and pizza, so you've got to kind of like. Oh, somebody posted something in chat. I was like, okay. So yeah, I mean, it's really odd. It's like, it doesn't have the same sort of effect. Like, because you're used to kind of seeing people and like having that sort of conversation with them, and then seeing things afterwards as well, and just saying like, oh, okay, yeah, how are you doing with this technology? How are you doing with that technology? Like, oh, okay, cool, yeah. And then sort of getting other people's kind of experiences. But you don't really get, it's not the sort of same. It's like you don't get the same sort of facial expressions and the same sort of passion. It's sort of it comes across kind of semi-monotonous, I think. Whereas kind of when you're there, it's like, I don't know, like maybe because there's beer and pizza, maybe, but like that sort of thing. It takes more energy to be a speaker on a virtual meetup. Oh, okay, yeah, I suppose there's that. But yeah, it's an odd experience. It's odd.
Yeah, I saw an article that said that why does everybody wave at the end of like a Zoom call? And the answer is like, because we don't have enough interaction, like we're not getting the full interaction. You have to over exaggerate everything you're doing and be like, bye everybody, before, you know, people will understand that you're going. Yeah, so I think it's just a very different experience. And Simon, yeah, I'm also looking forward to coming back to Sainsbury's and also having the beer and pizza and, you know, just all the nice things around it that, you know, make it fun.
Yeah, I miss the beer and pizza runs.
You remember that time when we had to run to the Sainsbury's next door because the order got cancelled the morning of the meetup?
Yes, I think we did very well there. Yeah, that was excellent.
Yeah, it was just like,
photo
wow.
Too. Yeah.
Yeah, just like a massive trolley of like 200 people's worth of drinks from the Sainsbury's next door. Well, I guess it's part of your building.
It's sort of in the building, but it's external, isn't it, to the main bit? So yeah.
Yeah, and you know, there's a lot of I find it okay. I find it. Oh, Brendan makes a good point. Allows for multitasking. I cook for the kids and now on treadmill. Like, that's pretty cool. Yeah, I think there's a lot of people who might be busy in the evening who can join on a Zoom call if it's not in person.
Plus also after the talks, when we're doing physically, plus after the talks, you get to hang out with several at the pub.
Well, yeah, that's the way. Yeah.
Who's constantly giggling away, as she is always.
By the time I get to the pub, I'm like, oh my God, thank God I'm done with the day, with the evening. I mean, it's great. I genuinely enjoy it. That's why I keep doing these meetups, even though it's not the same as being face-to-face. And like, I genuinely love it. But yeah, it's a different experience. Has anyone gone to a virtual conference? Tried these virtual conferences yet?
Yeah, I went to the Cloud Native Camp one, which was really awesome. It was a 24-hour event, loads of different speakers from various different places as well. Like really awesome event. Yeah, it's really weird. Like especially it's a 24-hour one. So like you're sitting there till about, I sat up till 11 o'clock, but there was events going up until about 1 a.m. on 2 different tracks. Because there's like speakers from like everywhere, just doing a whole meetup. Yeah, it was surreal. Like you're just going in there. Like you'd think that you'd have to fly there because I think it's hosted in America or something. I'm not 100% sure, but yeah, you just go there and it's like, yeah, here you go. Here's one track, 15 minutes, 5 minutes for a break, and then you go and just do something else. It's just really surreal. Like you're not kind of used to that sort of format. Kind of used to just sitting there for about 15 minutes or half an hour, sort of listening to one person or even an hour. And yeah, it's a very different experience.
I don't know, like I actually personally find it quite amusing. I attended AWS Summit and my experience was really pleasant because, I mean, like when you are physically there and you jumped into a room and then you realize that this topic is either boring or it's not actually for you, you might not necessarily have a chance to escape because you might be sitting in the front row in the middle of the room. So it will be just, impolite to try to sneak out. But when you just switch a tab and you're listening for another topic, it's rather easier to navigate. But also, I found it quite easy from logistic perspective because you don't necessarily need to spend time going somewhere. You don't necessarily have to take, like a day off or like, I don't know, like a few days off. Yeah. You can just jump in and jump out. And even if you missed something, the recording is available straight away. So you not necessarily have to wait for weeks or days before recordings are published.
I actually went to several of the several summits. In fact, there was a AWS summit. Then there was the Microsoft build as well. Okay, so quite a lot.
And what were your impressions?
Oh, the impression is quite good. I mean, the impression was quite good. That was one point that what the gentleman was saying about that. If you suddenly get into a track which you think that I'm not really that interested or I might get bored in the end, you can basically switch in the end. But then in the end, or even sometimes, if you do miss a topic by mistake or anything like that, you can just go back and replay it back again. Whereas if you go in a physical summit, once you've actually missed that particular talk which you wanted to go to but you couldn't, you could actually go and replay back, but you have to do it after a long time once they have uploaded them up.
Yeah, that makes sense. And Brendan, I see you asked, any idea what KubeCon is going to be like interaction-wise? I'm not so heavily involved with the event itself, like running that event. I have an idea. I think a lot of it's going to be through chatting, like with the speakers. I think almost everything will be pre-recorded and then replayed with the speaker there so that you can do Q&A with the speaker as you go along. But that's about as much as I know. And it was just announced today that KubeCon Boston is also going to be virtual.
Now we're living in an era of virtual events from now, until things get things die down a little bit. I think probably by the end of the year, all the events are going to be coming up. Are going to be becoming virtual in some form or the other. because I don't see any events coming back at least till the end of the year. That's what my prediction is actually. It's a dim prediction, but that's what I'm seeing.
I do
Yeah,
miss
so sorry, Danny, you
Sorry.
go.
Sorry, yeah. I mean, I do miss the selfie like that's normally taken at the front of the at the start of the conference that we normally do. So, yeah, that
Take a selfie like this.
Yeah, exactly that one. Yeah, and I feel like, how do you do that in a virtual one? Like, you've got to get everyone kind of together in the same, like, yeah.
Yeah, screenshot's not the same, is it?
There's a limit to the number of people you can get on Zoom.
Yeah, that's true.
Well, you know, I've got, how many people do we have on the moment? I think I saw 40 at the beginning. What are we at? 38. Suppose people could all turn on their videos.
Really? 30? I mean,
God, there's a challenge.
Yeah, let's see how many people will actually turn on their video.
I can turn it on. But you know, it's like it's in the evening, so
Provided your own beer, very good.
yeah, I don't have pizza, but at least I've got beer.
Sweet. Well, I think we got 10 people to turn their videos on. That's pretty good.
well, at least we achieved something today.
I wanted to go for a quick smoke, so maybe I will turn off first. And, yeah.
Okay, I'm going to do I'm going to try for a selfie with this screenshot, okay?
Oh, this is going to be awesome.
Oh, you can see my ring light in the side now, right?
We can.
There we go. That's my attempt to recreate my beginning of the meetup selfie, crowd selfie.
Cool. We're gonna see that on Oyshell, right?
Okay, I'll post it there. Yeah.
All right then.
Why not? You know, I'm actually bummed that I forgot that it was the third anniversary of Cloud Native London. I should have planned ahead and done something bigger for this meetup.
Right, you've got the selfie?
I got the selfie.
You know what? Actually, if you're really serious about it, to do an anniversary sort of thing, I think the very first time when we come back, like in normality as such, in having a physical, physical cloud native meetup, I think that meetup we should do as an anniversary meetup. What do you say, Cheryl, if you're serious about it?
Yeah, I'm good with that. We just have a delayed anniversary meetup.
Yeah, I mean, yeah, that's the thing. That's the thing. I mean, you can't really do anything about that, but you know, that's the thing. What I'm saying, that meetup would be the anniversary meetup. It's the only thing you would say. It's going to be a belated birthday, not a birthday.
It might be the fourth
Sounds
birthday.
awesome. The fourth birthday? Let's hope not. Let's hope it's before then. Alicja,
yeah,
you're back.
ready.
Do you want to take over again?
Yeah.
Thank you, everybody, for chatting with me. It's nice to talk to some people again. And yeah, we'll put on some nice food, very, very good food, the first time that we have a real face-to-face meetup again. And we'll have beer again.
Okay, let me do it like full screen. Let's present a slideshow. Okay, do you see my presentation in the full screen?
Looks good. It's all yours.
Okay, thank you. So thank you a lot for having me here. I'm working as you see, technical specialist in the Global Black Belt organization inside Microsoft, which means actually that I'm doing pre-sales. So my background is like, I've been doing Postgres for many years, never actually doing cloud stuff. So since I joined Microsoft, I started like to learn all the stuff about cloud. But actually what I'm still doing is just Postgres on the cloud. So today I wanted like to tell you a bit about one of our PaaS services, which is not running on top of Kubernetes, unfortunately, but you can have like a deployment of Citus on Kubernetes. We've got this brand new service, which is called Arc, where with Arc, you can absolutely run Citus on Kubernetes wherever you want, like on Azure, on AWS, or even on-prem. So it's kind of a new one. So under heavy development, I think it's still in the preview phase. But what's hyperscale Citus? Most of you, I think that are the people that like is still here with us. Those are the people that are a bit at least familiar with Postgres. So Postgres has got this API for extensions. We've got thousands of different kind of extension in Postgres, and Citus is one of them. It's not a fork, which is, you know, they haven't took like a code and forked it. It's an extension, which means that you are installing hyperscale like any other extension, like PostGIS, like Bloom, like any other that you used to use or use. And this extension is like turning Postgres into distributed sharded database. And because it is extension, you don't lose any of like Postgres capabilities. So you are able still like to use JSONB, you are able to add another extensions. You've got actually, there is no changes to your application code. It's just you're adding an extension to the Postgres. And why Microsoft likes hyperscale Citus? I really do like the story. I hope you will also like it. And like as a side note, if I would go like too fast, or I would start like you know talking something that like talking about something that is not fully understandable, please just jump in and unmute yourself and ask any question that you might have. Okay. Okay, so in the Microsoft, we've got this huge system, this huge database that is gathering telemetry from all the Windows devices from all over the world. And that's one system, one database. So you can imagine how big this database could be. And yeah, it's like in petabytes now. Like the chief principal engineer at Microsoft that is like that is working with this system, it's Min Wei. He's called Min Wei, and he was once driving home and was listening to a recorded conference talk about Citus, and they already had like some serious performance issues with the system. We will close the door so you know get rid of like background noises. Okay, so they already experienced like performance issues. It used to like at this time the system was using SQL Server, of course, because it's Microsoft, right? And it started to be really slow. So after like listening to this conference talk, he was like, maybe we should try it out, like this Citus thing, and check if that's going to be faster than our current database. And actually, if you would be more interested about that there's at least 2 recordings of Minway talking about the problem, how they tried to like overcome the problems with performance, and why they decided like to go for Postgres and for Citus. So they did POC, and like the results were really stunning. So they decided to move to Citus. And a couple months later, Microsoft acquired the whole company, Citus Data. And that's the reason we've got today Citus, hyperscale Citus as one of the options on Azure. Okay, about this system. It's called Release Quality View, RQV. It's got a lot of dashboards because, you know, taking the size of Windows business at Microsoft, it's really quite big. So those dashboards, this system is super important for a lot of people inside Microsoft, like engineers, testers, managers, and so on. Supports, like you see, over 6 million queries per day. And now it's not even 800 million unique devices monthly. It's over, yeah, it's at least 200 more. So it's still growing, and it's gathering all those diagnostic and quality metrics. So all the telemetry from all over the world. Okay, actually the current infrastructure, it's like they're using 2 Citus clusters. So in total, there is now like over 2 petabytes of data there. I know you see here like 1 petabyte, but it's like the slide is like from a year ago, but it's now like 2 petabytes of data. And still with those sizes, even like taking this old statistic 1 petabyte, still like a query latency is really, really low. So 90 and 200 milliseconds for 75% of the queries. And as you see, even like batch long running queries aren't really long running queries, because it's like up to 4 minutes. Okay. And as I said, like after the acquisition of the Citus data, we've got 2 options for Postgres now. We've got a Postgres single server, and we've got hyperscale Citus. It's actually Postgres extension, right? But this deployment, like it starts from 3-node deployment, because it's, you know, kind of distributed architecture. So it needs to have like more than 1 data node. Okay, just a quick overview of the architecture. We always have in the cluster 1 coordinator. It doesn't matter if we've got like 2 or 100 data nodes. It's always 1 coordinator, which, of course, as name says, it's like coordinating the whole cluster, the whole traffic that is going from the app. And coordinator stores metadata about what data are actually kept on the data nodes. So once a query goes from the application to the coordinator, because application connects to the coordinator, then coordinator like is parsing this query and is deciding about the query plan and deciding how to, in the best way, like divide the query. If you know like MapReduce, I think most of you do know MapReduce. It's kind of the same approach. In the summary, you always have coordinator, and you've got two on Azure, at least two, up to 100 nodes. And it's sharding. So sharding, actually shard means actually Postgres table. So normal Postgres table as you have, like if you're doing create table. But this shard is keeping only like a part of the data from your actual table. And the default number of the shards is 32, which is pretty much independent from the data node numbers. So if you've got, for instance, two data nodes, as you still have like default 32 shards. So it means that on each data node, you will have like 16 shards. Okay, let's let's go to the terminology to So let's start with the coordinator. It does store metadata. And application do connect to the coordinator only, and the coordinator is then spawning like the job through the data nodes. Worker nodes or data nodes, so both names are okay. Those are actually storing the data. So there is no or real little amount of data on the coordinator node, and the nodes that are storing the actual data are data nodes. Sharding, that's the process of dividing data among nodes. And shards, you may think about shards a bit like partitions. It's kind of similar concept. So shards are like normal Postgres tables, like keeping only part of the data inside. And some of the nice features like collocation, which I think it's really a nice one, because if you've got a table and like related table, Citus will like split the data in that way that related data from those tables will be kept on the same node. It means that if you are doing joins and you are using in the work loss, because it's very important that you are using in the work loss some column that the data is sharded on, then Citus has got this capability to not like use all the nodes to make the computations, but just go to one node and like do the join locally and then send the result of the query like through the coordinator to the application, back to the application. It's a bit how it looks like. So metadata, so coordinator having those metadata, he knows like where to send the query. So he doesn't need like to use all the nodes to make this query, only one where those data actually are. There is another nice feature, which is free balancer, which basically means that if you've got some spikes in the activity or your data is growing, you can add additional nodes to the cluster. So let's say you had 4 before and you are adding like 2 more, then like automatically in the background, Citus is using Postgres logical replication to send over the data to new nodes. And then like after the operation is done, it's changing the data in the coordinator, and then like you can use your application can use like more compute power. Okay, another important thing, because Citus is Postgres in extension, so it's actually Postgres. It's like not violating any ACID rules that Postgres has. It's not like NoSQL database that is not always consistent, you know, like eventual consistency and so on. It's normal, like full, so strong consistency because like Citus is using a two-phase commit protocol. So you can be sure that once your transaction is committed, it's those data will be there, like independent of this, like distributed cloud native and more buzzword, you know, architecture. It's like a fully ACID compliant still, like Postgres is. Okay, let's go to table classification. We've got 3 types of tables in Citus cluster. And the most interesting ones are distributed tables, because those are the tables that are leveraging the most Citus capabilities. Actually, the aim, the value that Citus is giving to you. So those are the quite big tables. You know, this 10 gigabytes doesn't have to mean anything. It's not like a straight number. You may have like a table that is 2 gigabytes in size, but it's worth to shard it to make it distributed because it's got like sharding key and you can do it. So of course you can. And collocation, so this cool feature that I told you about, is using this type of tables. Enables, of course, like fast join, because like local join. And you've got one single function inside Citus that you can use to tell Citus that you want this particular table to be distributed. You are just adding table name, column name, and yeah. And Citus does know that it's going to be distributed table, so it's starting to splitting it into shards and like putting that on different data nodes. Reference tables are like mostly dictionary tables. If you are doing joins, so probably you need to have like the whole dictionary to make it. So you need the whole copy of the table on each data node. It's rather for smaller tables, not only dictionaries, of course, but mostly dictionaries. And you are declaring the table as a reference table in pretty the same way. So using the function, and you are giving as a parameter the name of the table. And local tables, those are like the most boring one, let's say, because if you don't use any of those functions, I mean create reference table or create distributed table that are shown here, those tables will be created on the coordinator node. And it will not be distributed. It will not be replicated among the nodes. So probably only if you have, for instance, like a kind of software that is tracking code changes, like Flyway, for instance. So you probably can have there like a small table that is like keeping changes there. And in the Azure, you've got this switch. You can declare, you can choose that you want to have HA, which means that the whole cluster will be created in another zone and will be connected to the main cluster with Postgres synchronous replication. So in case of any failure, any problems, then like there is completely automated mechanism that is doing failover for you. Your application is connecting using DNS. So in case of failover, this connection string is not changing. It's doing like failover in the background and like assigning this DNS to the new cluster. The problem with that is the price, because in Azure Postgres deployments, what you are paying for is basically the infrastructure. So if you've got like a 3-node cluster, then you are paying for 3 nodes. And if you've got like a 6-node cluster, you are paying then for 6 nodes. So with HA enabled, you basically paying like twice the price that you would pay for single, like a single zone deployment. So the price for sure, of course, a bit bigger latency. It's like a super fast connection between zones in the Azure, but still with synchronous replication, you always have a bit bigger latency. So yeah, it's something that you need to take into consideration. And like before maybe going there, just like a private note that I was working with Postgres like for a long time, and like a couple of years ago, there's been like no solution that would resolve a problem with a huge amount of data, like terabytes of data. I don't say 4 or 6 terabytes, because that's the amount of data that single server can handle without a problem. But if you've got like 50 terabytes of data, or like here like 1 or 2 petabytes, then single Postgres server will not handle that. Yeah, I can like bet with you that it will not. So there's been no solutions like that, and I say that like in the past couple years, those solutions like are created like in a really fast pace. And I don't say that Citus is like the best ever. I say that it's really good solution. It's really major solution, but you've got like another proposition like CockroachDB. You've got the new one like from TimescaleDB, because they trying like to do some actually similar solution. It's in alpha or beta now, I'm not sure. At Postgres XL, BDR. So we've got a lot of that, but I'm really happy that those solutions are like popping out, because it means what statistics are showing us actually, that Postgres is becoming really one of the most popular and one of the most loved database, as Stack Overflow survey says. Yeah, I'm really happy to do that, and that we can finally solve this problem at scale. So with really big amounts of data, we don't have to like use proprietary, really expensive, solution like Oracle and other stuff, because this kind of architecture, I'm doing a lot of migrations now, like from Oracle to Postgres. And in many cases, for many workloads, Citus is much faster than Oracle, even Exadata. So, of course, not for all of the solutions, because there are like specific workloads where Oracle is faster. But for a lot of workloads, this is much, much faster. So I'm really happy that open source technology like taking over. So migration resources, if you like would consider like migrating to Azure for that. Citus is, by the way, like open source, so you don't have to like pay any fees for using it, any license. If you want to like install that on-prem, you are free to do that. This is open source extension, as I said. But if you would like to migrate to Azure, there is like a lot of tools like a database migration service, which works for both single server and Citus. And like I've pasted you the link to the slides. So yeah, absolutely. You can check the tiers that we offer and like documentation, forums, and so on. Okay, it's pretty much late, so I think I will finish now. And if you've got any questions, then please.
Awesome. Thank you so much for sharing. There's a question in the chat for you. Do you know how the Azure implementation is different to AWS Redshift?
I do know only Aurora implementation. I'm not aware of Redshift. So I can compare that to Aurora only.
If I may sort of like elaborate on this, I mean, like they position Redshift as data warehouse. So I was slightly surprised to learn from your talk that there was a problem with scaling with like huge data sets, because essentially it means that they somehow like address this problem, because data warehouse is usually quite huge.
We do position Citus as like a solution for HTAP workloads. So like mix OLTP and like OLAP.
Okay.
That's the best like workload that fits into Citus. So that's for analytics, for warehousing stuff as well. Although like a lot of people from Microsoft, because many years of using SQL Server, like changing the perspective a bit. So many people like more likely to propose you signups. But absolutely, that's for those solutions as well.
Everyone will be driving solutions they're comfortable with, just like
absolutely
serverless and Kubernetes.
Yeah, that's right. We are trying, to shift this like mindset, let's say, but it's not like a fast process.
Yeah, people or like human minds are usually the biggest challenge for every project that you may want to do.
That's true. But with Aurora, I know that Aurora has got like, only shared storage. So it's not like Citus, because Citus, if you're adding nodes, you've got like better performance both in reads and writes, because you've got like separate nodes. And, I know with Aurora, it's only like scaling reads, not writes.
Okay, thank you.
Hamad just asked about more resources. I guess those are in the back of your deck.
Absolutely, or you can like Google Citus data, or Minway. He's got like nice presentation about like this, kicking off SQL Server.
Awesome. We're basically at the end of our time now, so I want to say massive round of applause. Thank you to all of our speakers who've come and spoke for us today. Thank you again to the sponsors, and we're going to be back again on the 5th of August, the first Wednesday in August. Simon says that there are still jobs at Sainsbury's, so please feel free to apply to those if you want to. Otherwise, thank you so much for sticking with us. Love seeing everybody again, and we'll see you again soon. Take care. Bye-bye.
Cheers, everyone.